Wow, everybody's getting wrapped up in their midterms, right? They'll probably roll in.
Mine are all next week.
Oh, good.
Besides, working on the project slowly. I just started on that already.
Of course. Of course. Getting the project's all done. All that good stuff. Well, and we're going to talk about a couple of presentations here. Units 19 to 24, which is framing. And we're going to talk about the other unit as 24 to 28. And so we'll get into those things today and then introduce the next homework, which starts at unit 11. And then you guys can have time to start working on that additional homework or your group projects. Remember that the group presentations will be next Friday. So next Friday in class, hopefully everybody is ready to go. For those that had Jose in their group, he has withdrawn from the class. So he had a car accident, so he's going to try to rejoin next quarter. So, if you guys know him, sorry about that. Sorry about that challenge. So framing. So framing, is the underneath skeleton of the building. So in the case of wood, it's 2x4s and 2x6s, and then other kind of truss elements or truss joist elements, LVL elements, and it's also has to do with the metal pieces that tie all that together as well. So in California, we have a lot of metallic connectors to connect it to the foundation, and then to connect all of the framing pieces together with each other to keep it from shaking apart in an earthquake, basically. So we have to do extra kind of connections. So for this, we're going to talk largely about roofs. So in this, we're going to talk about trusses and roof framing, and then start into looking at the calculations for actual rafters, calculations of sizing of rafters. So let's start in with one element that has to be framed, and that is windows. Windows and doors have to be framed in, and we get elements from a manufacturer, which is called a cut sheet. There's also an example of this. There's an example of this in the book as well. So a basic window. Oops, I need to move over a little bit. So we're going to get this cut sheet, and let's say, for example, we're going to look at this window that's called CR125. It's 2 foot window. 2'4" is then going to be the size of the glass, right? So they're giving us the size of the glazing here: 2'4" clear, and then 1'5" in width for this column here, right? So this column is controlled by these dimensions. So the rough opening for this, basically a nominal size of 1.5 foot or 18-inch window, 18 by 24 nominal size. But you can see that it's not that size. The actual size of the window is bigger, and it's bigger because the framing is larger, and you want to have that size of a window open. So the window frame has to go on the outside of that to hold all the glass and hold the hardware and all the elements of that. So what we need to know for framing from the cut sheet here is how big to make our rough opening in the building. So that's this column, this row right here. And then the column that shows you the rough opening is, so the rough opening this way is shown along the side here. So for our 125, the rough opening, 2'4" 3/4. The minimum rough opening, and then the minimum rough opening here, 1'5" the other way. So it's a little bit compressed. It's not quite 1'6". Does that make sense? So that's the thing the framer needs to know what window's going in there, so you put the correct rough opening. Then the window goes in there. There might be some shims to make it level, and then the framing it gets nailed into place and everything around the whole window. And then the shell trim goes on the outside and the inside, so that seals it up. And then on top of this, we're going to have flashing before we put the trim on. So you put the window in, you put the flashing on it, and that keeps the water from penetrating back into the wall framing. So that's the really quick window spiel. So how a window is framed, or a door. This is a door frame, and we know it's a door frame because there's no bottom plate there, and this would actually be taken out for the door opening to be put in there. The rough frame would not continue all the way through. So a door, like a window, requires a header above, and that header protects the door or the window from any crushing of the structure from above. These guys, these are called cripple studs, and they're put in there at the same spacing. So if it's 24 inches on center or 16 inches on center, then the cripple studs are put in there at the same spacing. The king studs are the ones that go all the way up the whole height above the header. The jack studs, they jack up the header, so they're the ones that are underneath the header. And then how these headers are made up. Thank you. So the headers could either be a solid piece of LVL, which is layers of wood and they're glued together, or you can make it up out of dimensional lumber and a piece of 1/2-inch plywood. So this is what you would do in a 2x4 framed wall system, because there's an 1.5 inches here, 1.5 inches here, that's 3 inches. And then a typical stud is 3.5 inches. A 2x4 is not 4 inches, it's only 3.5. And it's not 2 inches in the other way, it's only 1.5 inches. So if these standard sizes, so 1.5 inches, 1/2 inch, another 1.5 inches, that gets us the exact width of a 2x4.
Is the plywood added in there so it bends?
Yeah, so to make the header stronger, they'll typically also glue it on both sides with construction adhesive, as well as nail it in a pretty, 6-inch on center nailing pattern. So that header is like it's one piece of wood. So that's the purpose of taking that plywood, getting the extra width. Because if you just had 2 boards sitting there without that plywood in the middle, they could actually flex. They could actually structurally flex, but this puts it all together, makes it like a little mini beam, and makes a stronger member. So window framing, real similar to door framing, except for, of course, we've got the sill. The sill plate is what the window sits on. The bottom plate that the window sits on is called the sill plate, rough sill. And then these are also called cripple studs underneath the sill. So they're just shorter. They fill in underneath whatever openings you have there. Roofs. So we're getting into roofs here. And the most common forms of the roof. The very most common form, gable roof. You see that everywhere. A little bit more sophisticated version of that is the hip roof. So you've got the gable, and then you rotate that back 45 degrees or 23 degrees, and then you've got the hip roof. The shed roof, that's just a single plate that goes in one direction. Gambro, that's the old style barn roof. And then mansard roof is actually this kind of a Dutch situation there. Trusses. So these are the elements of a typical truss. So the bottom cord, that refers to this member that goes the whole length of the bottom of the truss. top cords, these are the top members, similar to rafters. They'll have the tails, which goes over in the soffit area in the overhang. And all this is tied together with structural plates called gussets. And they could be individual wood plates nailed, or they could be a special nailing grid that they nail onto there with a nailing machine. And the span of the truss. So the span of the truss refers to not the tails, but the point of the truss that sits on the wall. So in this case, the tails are going to go past the wall to create the overhang of the soffit. And so the span is actually to the end of this bottom cord of the truss. And then these members here are known as web members of the truss. The rise and the run are important. So the rise of the truss is the total height from the point of support to the very top, where the top support was. That's the rise. And then the span, of course, would be that. And then half the span is important because that tells you what the actual run is. So the rise is this amount here, and the run is actually this amount to the center. So a roof is typically mirrored, and so the center point is important. So with rafters, so before trusses, trusses are kind of a manufactured sort of an item. We had to make up the roof members individually out of rafters and individual pieces of wood. So the way that works is you cut out a little piece of the wood called a bird's mouth, and that helps it sit down onto the top plate of the wall. And then instead of having truss members in here, we tie the roof trusses, rafters together with what they call the collar tie. So this keeps it from spreading out. If you don't do the collar tie, those rafters have a tendency to flex outward. And then this is like a ceiling joist member that runs across, and then you attach the drywall underneath there to finish off the ceiling. So this is a more detailed version of the bird's mouth. So you see we've got the stud, the wall stud comes up here. We've got a double top plate, 2x4s. And then these are the ceiling rafter members going across, ceiling joists. And then this is the ceiling rafters sloping up for the roof. Once again, that overhang, so the tail is the part that hangs past, and it makes the overhang. For the trusses, you don't have to worry about measuring lines and stuff. You buy them from a manufacturer, you get them delivered to the site. They're all done in modular, and then you just pop them in there every 16 or 24 inches. But these, you have to make them yourself, so you have to know the measuring line. So the measuring line for measuring the rafters is the center line of the particular board. So for example, if this was a 2x4, the center line, would be 1.75 inches down. So that's the measuring line for doing the length of the rafters. So the carpenters have to figure this out on a roof-by-roof basis. Trusses. Trusses make life easier, you can imagine, because you don't have to manufacture all of these various parts for the trusses. And we have different types of trusses. We've got trusses for end conditions. We've got trusses that are called piggyback trusses. There's two elements to the truss. So for example here, the truss is so big that it has to have a piggyback element on top of it. This is only the bottom portion. And then you'll have this portion which sticks onto the top of it to make the entire truss. So it comes in, too big for the truck, and then they have to assemble it in the field. Other trusses are just intermediate trusses that go into the middle of the building. So they won't have framing like this. This is the framing for the end condition so that they can nail all the various pieces of siding to the outside of the house. Whereas the inner trusses, they don't have to have anything nailed to them. So they're just a typical truss structure with the web members. What else? So in this case, these trusses, they have an ID T01, T01GE, that stands for Gable End. And then T02, that's a piggyback. Right? And then another type of piggyback, T02A. So these are different, slightly different trusses in configuration. And GE3 is another piggyback truss for a gable end. And then this is other top parts of the piggyback trusses. There's the top of that one, and the top of that one. So they call it piggyback, whereas these are individual trusses for a different roof configuration. So when you order the trusses, they'll give you this. This is the delivery sheet. So this tells you the list of all the trusses that you get and how many of them. How many are supposed to be in the order. So this is a very important thing on the job site to make sure that you receive all of the proper materials. A typical framing plan layout. So this is also from the book. So a framing plan will tell you which truss member is there, that T01GE, that's the gable end truss. And then the spacing here, and then what the trusses are. These are the inner trusses. Well, that's hard to read, isn't it? 244. 240, 244. Oh, okay, this telling us the spacing. So vertically here, telling us the spacing between the trusses, 16 inches on top. If I zoom out, if it's better. Not really. So check the book in this chapter 20. Now here's the typical design sheet for a truss. So at the truss company, they're going to have to design the members to make sure that this truss will support the weights that you need it to support. So they go through their computer and they figure out, okay, we need a span of such and such. So we need the span of, 18 feet, and they need a truss that's 9 feet tall. So then it designs the strength of all these various members. So in the truss, it's supporting here, and the weight is coming down like this. So some of these members are in tension and some are in compression. So it's based on where you're located in the truss, but that's neither here nor there. Compression means that the forces are pushing down. Tension means that they're having a tendency to pull apart. So the truss design will take into consideration where the tension is and where the compression is, and have appropriate fasteners and connectors for that. Just more detail about these trusses. And then this is kind of how you would frame out the gable, the end condition. So this is the gable end truss. It has the additional vertical stud members in it. And then you frame out this ladder out to the outside. And then usually you'll attach some plywood to the bottom of that and have ventilation in there to make sure that everything's properly ventilated. And so inside the building, where it's not a gable end truss, this is where you can have this open web truss. And then just talking about the piggyback truss, this is the upper piece for the piggyback truss. They did the calculations for that, the calculation sheet. And this thing sits on top of the overall lower part of the truss. and how the roof is put together. So whether, whether this is a truss or whatever, up above, the roof is going to be in a similar configuration. You're going to have the sheathing, roof decking, which is usually 5/8 or 5/8 plywood. Generally, you can use chipboard, but it's not very good to use chipboard for your roof. But you can save costs by doing that. I still recommend plywood, marine grade plywood, because it's the roof. It's going to be exposed to a lot of conditions. So on top of the sheathing, there's underlayment. So we now use rolls of 50-year plastic sheeting, which will, it lasts a lot longer than the felt paper that used to be done. So there's a couple of grades of felt paper. There's 15-pound and 30-pound. And some people used to use a 15-pound, really cheap stuff, throw it out there, and then put the shingles on it. But then that fails after 20 years. So we now have some materials for our underlayment, which will protect the underlying roof, which is more compatible with the tile roof system, because a tile itself, a concrete tile, will last 100 years. But if you have the paper underneath failing every 20 years, that's not an effective use of your materials, because you got to keep pulling it off and reinstalling the underlayment every time that fails. So 15-pound will definitely fail within 30 years. So it kind of defeats the purpose of the 100-year material, and you have to keep dealing with it. With the rafters also, there's a ridge board involved. So the ridge board is what the rafters are nailed to at the peak in the center of the instead of the roof. The ridge board, that's something that you don't have in a truss situation. You might have some blocks in between it, but there's no continuous, board like this. This is one single continuous ridge with rafters. Framing plan. So this is the roof framing plan for our lake house. And we can go over what's going on here. So these are 2x10s. 2x10 piece of wood is 1.5 inches wide by 9.5 inches tall. So 2x4 is nominal, so it's 2x10. These are nominal sizes. They're not exactly the size that they are anymore. This one. So this member here is a steel member. It's an MC, metal channel, and it's specified there how big it is. This PowerPoint is not zooming in too well. Once again, 2x10, that's 16 inches on center. So our 2x10s are marching along here, this part of the roof. We have this center part, which is kind of flat shed roof here. And it's also 2x10, 16 inches on center. Now this ridge is a 2x12 ridge. 2x12, it's a piece of wood. Whereas this ridge here is a piece of metal. And then the rest of this is 2x10, 16 inches on center. Yep, that's our roof.
Why not make it on uniform?
Yes, it's. I think they're trying to demonstrate metal channels to it. That's the way they did this design for this lake house. So the lake house has these steel columns in framing below, and then goes up to the roof. It's kind of a funky framing system. Tried to get fancy in the 70s.
Typical houses will have very uniform, right?
Oh yeah, typical house. Yeah, they. I don't see the reason why they had that strange ridge. The metal channel. You would just ordinarily use a 2x12.
2x12?
Yeah, typically.
And that's the entire roof, right?
Yeah, 2x12s. So then the ridge is, they want to be a little bit bigger because the rafters connect to them. So if it's 2x10 rafters, then you need a ridge that's 2x12. Because once you cut it, it's on an angle, then you don't want the rafters hanging down from the ridge. So you want that full connection of the ridge there. Okay, look, that's exactly what the slide is talking about. So 10 to 12, that's the slope, right? 10 inches of rise, 12 inches for every 1 foot, 12 inches to run. And a 2x6 rafter will require a 2x8 ridge board because, see, if it was only a 2x6, it would be up here. You know, it'd be 5.5. So it wouldn't be completely in contact. So they want the ridge board to have the rafters in complete wood contact with that ridge board.
And it's L brackets.
Yes. Yeah. And then, you know, in the old days, we just nail it through, right? But yeah, now we have to do so much metal. I mean, all this stuff has, you know, so keep in mind, this building was designed in 1970 before the big earthquake. And so there was many changes even nationwide to the way buildings are built. Like even in the Midwest now, buildings have to be anchored to the footing where they didn't used to even have to have those anchor bolts. It wasn't required. You do it if you want to or you don't. But so we in California, even up to the most recent 2014 earthquake upgrades to our codes, we constantly have to stay on top of it and be having the latest practice. So honestly, the latest practice would be probably not even going to use rafters. We're just going to use trusses for mostly everything. It's just a lot faster. You fabricate the trusses in a shop, and then you have them shipped to the site. Whereas these, each and every rafter has to be fabricated in the field. So that's a lot of labor, and labor is a huge, huge portion of our stuff. So it's easier, it's more effective to have people build these trusses in a factory situation where they're building trusses all the time. They're really good, really fast, really cheap at building trusses. Whereas carpenters are hard to find, so you need carpentry skills to make all of these various rafters, the ridge boards, and do all that. Some more details for our building. Our lake house, we've got a few different conditions here where the roof has been connected. All right, there's this condition where it's face nailed in to the edge here, and of course you got to flash this in. So the flashing and counter flashing is important to keep the water out. So flashing comes down here, and then you have counter flashing that goes back up there, and then this flashing you make sure that it goes on top of whatever roofing system you have. So this keeps the water out. Okay, the next condition, we connect to a beam with this condition, with the LVL. So then we've got to have the hanger that connects. And you got to be very careful when you connect through these truss joists that you're connecting to the top and bottom portion, because you can't cut through the web or ruin, you kind of ruin the structural integrity by cutting too much through the web. And you can't attach to the web either. You got to attach to the top and the bottom of an LVL. So that's that condition. And the other one's a ledger condition. So we put a ledger on the outside of the 2x4s, and then you put the rafters nestled on top of that. So here's another look at a rafter system with a hip roof. So with the hip roof, you can see that it's pretty complicated, right? It's got these two angled roofs coming together, and so these rafters are called the hip rafters, and then the smaller ones, any one smaller than the full-size main rafter, is called a jack rafter. And so these are called the main rafters. Common rafters or main rafters are the ones that are all the same length. on either side. These are the ridge boards. So there's ridge boards at every ridge. And there's valleys also. So the valleys are sunken down. The valley ridge, the valley jack rafters are the shorter ones. Shorter ones than the common rafter. Does that make sense? So the valleys are going in and the ridges are going up. Just a little bit more detail about that. So if you've got, get this 28 foot here, then it's going to be symmetrical 28 feet this way as well. All right, so you know this is a 45 situation on a hip roof. So when you're figuring out the dimensions. Other parts of the roof, cornices. These are the trim pieces on the end, and they're also known as fascia. So the rake cornice is on the end gable, and then the cornice at the eave is going along the length of the building. So this condition is called a box cornice. It's pretty commonly used. You've got ventilation through the rafter system, and you've got a piece of plywood on the bottom. This keeps, keeps the birds and everything from coming and make their nests up in there. And then you've got fascia, and then molding, and then your roof structure on top of that. So this end piece is called the cornice return. So you fill that in, same reason, to keep the birds and stuff out, and the squirrels. Another way to do the soffit is just straight down with a piece of plywood, right? It's a lot simpler, just straight down the rafter instead of building out a box, which would go something like this. It's just another condition that's pretty common. You could even also, they do this a lot in California, just leave this open, and then you ventilate your roof structure from this plane here. So there's a lot of different ways you can detail the edge of the roof. Very important stuff though here is when you're doing your roof, you make sure that you have a drip edge here, because the drip edge goes a little bit past the edge of the fascia, and it takes the water off the roof, and then it's not running back underneath your shingle. So if you didn't have this drip edge, the water would have a tendency to come back in underneath the end shingle. What else here we have to know? So this would be how, in this condition, this is really tight. So there's a very small overhang here. There's just enough room for a vent. And so the siding would come up. You have this little ledger board, and then you finish it off with a piece of plywood. Just another way of doing it, right? Straight across. We always have to have ventilation. Make sure we always have the ventilation in there. So we have to be concerned with truss choice. These elements, like I said, this plywood web is really sensitive. Sorry for the blurriness of this thing. There's a better picture in the book. So this is like an LVL member, laminated veneer, wood, top and bottom. So his has to be trimmed there. The bird's mouth can only come out of that part. It can't come out of the web at all. Okay, and then if you do have to do that, then you have to reinforce it next to it with fully reinforced 2x4s. All right. This looks like a good stopping point, you guys. Take a break here until 11, and then come back.
So I got a question. So what is this, like, how do I know which one I want to remember that. So these one. Yep. Yeah, that's what I have for. And then the second question is stabilization. Yeah. Yep.
These lines are the natural elevation, right? And then these lines, the lines that are attached are what's going to change. So after they finish landscaping, it's going to go from this, okay, sloping onto inclination over here. It's going to be sharp. They're going to take this 326, lower it, and they're going to add, so they're going to make this more tall.
So they're making 328, like,
It's not going to be like this, it's going to be like this.
what's this elevation, what's that elevation?
It's just in between, right? So everything is like, right now, they're asking questions like right now, this pine tree is like, it's around 327. But once these are moved, it's going to be closer to 330, 332. You know what I mean? So, yeah. It's represented to like, okay. So we have like a lot. Let's go to that makes sense. Project. It's too next slides. Presentation.
So we have, okay, how do we do it?
No, it's a really good. You need a microphone for your so.
Oh,
Honestly, I forgot to attend. That was a show coming, so. Everyone's here.
I didn't know what it
Yeah. Do you see anything about the midterm center?
Which one?
The
Group or individual?
individual.
Not much, really.
Like, we're not doing it today, or It's not, it's, we can just do it whenever, like, it's not like a class assignment.
Yeah,
Oh.
yeah, I think we turn it in November 8th
Oh.
online.
Okay.
We started it.
Have you started?
Yeah.
Oh. I mean,
I don't have time next week, so I'm
Okay.
like trying to get
Yeah.
ahead.
I thought it was something that we were going to be doing in class.
Oh.
I thought that's what he said. Like, do class.
I think he might have said that we want time for it.
Okay.
Nothing going?
The individual midterm assignment is like, we just turn that, we just do that whenever, and we turn it in, you know, on the day, but like, it's not an in-class thing.
You can work on it in class?
No, yeah, but it's.
But, yeah,
Okay,
yeah, right, it's not a presentation involved.
gotcha. So, yeah, so this is natural gray. Okay. It's like, this is like, you know, like it's a natural elevation. And then final gray, this is black lines, right?
But it's like this is not nowhere near, so this is still in there.
Yeah, but I think this one's close enough. Right. So, okay, yeah, whatever you mentioned then. Yeah.
Why didn't you have that?
No, I just eyeballed it. I didn't. You're probably right. You measured it. So it's like this is hard. It's like
I know.
kind of has he talked to you before?
Probably 10 times. I've been on the phone.
I water bottle in my hand and I'm asked like this, and I'm like drinking water. He walks all the way over. Drinking water.
Your
And
budget?
he's like, he says,
Oh, yeah, I guess it's kind of there. I'm Googling who's great building plans.
I feel like first few hours of really rough. If I can answer, you're gonna be
Hey,
like
what were you saying?
getting stuck.
Yeah, so
Be
basically,
like, what the heck, man?
you're
Oh, I
comparing,
supposed to
between
it gets a little.
the natural
I
and
don't know
wild
if it
elevations.
gets easier
So you have to
after
find
a
out,
while, or if I just start
for
caring
example,
less.
and if you're gonna want this new garage has to be
So I
at
just start caring. So how late
It's
to
elevation.
do
And really, the only thing is that
to each component.
here's
You spend time
342,
Google here.
right?
I was gonna use the
40,
text.
342 is
The
the
inside book, I think chapter,
So like half of this
I think it's
garage
chapter 4.
is
Talks
gonna
about,
be less than
plans
343.
and who will.
So you're gonna have to fill
See, I have 22
just right
components.
here for this foundation. I think that's gonna be,
Components.
you can ask him to be sure about it, but it's like that, like, you know, this station's at 337.
Yeah, it should be 16 or 6 or
I
recently
looked at them, yeah,
recently updated
so,
You know, it goes over here,
you need division.
so it's, you have to
Track
figure out something that's not right there.
Not,
Uh,
no.
It's kind of.
I always get them confused.
It's weird.
I haven't, this is.
You're talking about this one, right?
Yeah. Yeah, we should talk about it.
Okay, so,
I'm pretty sure it's chapter 4.
I don't know, I asked the professor, I found the link. Do you know how one of the questions is sheet number and letter?
Yeah.
Yeah, so I was going, at first from, the type of drawings they have, right?
Yeah.
Kind of, is, yeah. It's a list. It's not,
So where do you go?
on the website.
Is that what you're doing to the top?
It's not in this one, is it?
And this is all.
This is the division. This is like something.
Okay, there it is.
Is that what you were doing with this?
No.
There's another list here. I'll show you the other. We.
Yeah, he's talking about.
So, are you talking about this list?
Yeah.
Not that list. Okay, well, I thought that was the original list. That's what I was originally doing my comments off of. But then I read the like questions or like the example cover sheet, different types of plans, sheets, and schedules. Okay, well that was not listed on the. So then I have to have this list. Here, that's the cover sheet. These are the sheet numbers and letters. I found it in the sheet numbers.
Yeah, so this is, yeah, because it is, so the sugar,
Yeah,
the sugar talking about.
I Googled it. But I put everything up there up until today.
Yeah, I live in.
So like, I got over most of it, and I didn't find the book extremely, like, the answers that I was looking for this problem. I didn't really bother. I read through this all before, and I was just like, I didn't go wrong.
So it was this what I was thinking.
Yeah, that one was T number. But that's confusing, like, I don't know. It's still Truss. Oh my god.
Yeah, that's like, you want to see. I want to see.
I have that concern.
No, no,
Are you sure?
so would you find a net?
Art toolbox. Yeah. But, yeah, I took away another submission yesterday.
Geometry.
No, not.
So I'm studying that.
We don't have to wait for me to like
Brain water to get to it.
Silent two or the system? That is what's up.
Yeah, I
I
had
can feel more like.
a Red Bull
I
yesterday. Oh my god,
like
I
lower
finished
my
one.
stress a lot.
I had a Red Bull yesterday too. That was after we finished.
Because some things like if you ask for it, like it's very specific.
Oh my
Like
god.
there's like
Yeah, it's
It's not
crazy
like
how
100%.
specific that can man.
like we're doing kitchen stuff like
After the T number letter, there's the question.
like I know that the dishwasher, the trash, they're like the wall cookies and they got like sticky line. That's
I mean, that's just, yeah, that's something you watch.
It's no, and for another change, you're saying?
I hope
Yeah,
you
sheet
know,
numbering
I'm sure by the time it's the 17,
But then he's also asking for the order.
He's doing even show us how
I didn't know
to
that.
put
The first two, second two, whatever.
yeah, 'cause my shit's gonna be two floors.
Like, what can you possibly do?
I'm gonna ask her. Hold on. Or actually,
You know, like
I think it's really just like, I think like really, the scientific stuff that we need, so you just like, have those in, you just keep chilling us.
because if he doesn't like you, really, why like
Did you get your windows fixed?
Hey, he's gonna,
Yeah.
you get teeth, really, let's say,
I
it's
thought
like,
it
oh, you have something
Friday.
good, like,
It's like, it's
it's like
hot.
the back of the symbol of one story.
How much did I end up charging? That's not too bad.
Yeah. It could have been more close.
Yeah, that's a.
No, okay, it didn't text me that.
No, no worries about that. I'll try.
By the time I finish this song, you can watch
Yes, it's like a machine feature elevation, and this is probably top of our hair. It seems to help you. Anyway,
We are. So it's good for the technical building plan. That's where it kind of puts into the page.
yeah.
I just went without this just because it had all the letters already. Make up the letters.
Yeah.
So I was like, you know what? I feel like that's because when I tried to make my original list I showed you, and I tried finding many letters, it's like work, like that was nothing.
You know, like half of them are
Like
like easy,
spelling,
like once
like
it's
either
easy,
landscape or
those are like the weird parts.
You can like control control V, the question is
Forget it.
what you.
I don't know, components,
What?
something for soil,
That's like,
something.
Yeah, mine's.
yeah, there's like,
Geotechnical. engineering.
I
think that's what it is.
I think on the textbook they have like what.
And you know the-
Yeah, like what machine is. I don't have it on me.
Soils? Yeah, sure. I didn't know, I've never heard of shit technical.
Yeah.
Any soils?
The engineering, understanding the flow, position, and the contour.
Number 8.
Yeah, it makes sense, because right, you get to know how it's gonna withstand the weight of it.
Yeah,
If it's like
especially
more,
for like
it's
the
gonna
bigger
hard.
ones. And I think you're also going to look at the property lines of your property if I'm wrong.
You really met 12:30. You really met 12:30. Oh yeah.
And the thing is,
I'm making that right.
So the architect doesn't cover, I think we do the general,
that
And,
was
like,
so fun. Alright.
but then once you start getting into the civil, technical, geotechnical, there's all engineers doing it. So they do the, they write up the report, and they approve the report, unless there's like. You know, because they got it, it's my house. It was hard for me to find all of it. I was like using it for concerts to like see if I could find better information on what they're doing. Coverage sheet, architect, architect. I'm not sure. For almost time. Overall, recommendation. After this material, we've got a company. Handling materials.
It was.
That was like one of the. of those people because they would be for landscape. Project, work or something. I told them to do here's the things like what you're like. So, yeah, I'm gonna start something. But those are, that's what I'm saying. Yeah, so it's kind of, if there's an engineer who does the plan, they're usually the one who does the plan. Two, unless there's another outside board, so it's like, I need to approve this. No, it's not all good. Yeah, that's how I felt when I was researching. I was like, oh, great.
It's gonna be all Sunday.
All right, let's move on a little bit to the next thing about some more about windows and doors, and we can talk about paving surfaces, other site-related information. So more details about how windows are put together. The names of all of the various parts of the window. And this is also from the book, so you could reference this if you missed out on anything here. The rails, these are the parts that hold the glass together. Stops, so the window is going to come to some point where you want it to stop. The head stop up here, that's an area. The glazing is also the glass. These little bars that go are called muntin bars. The vertical members are called the stiles. There's some kind of, the nomenclature of the names of the various parts of windows. So this is a section to the window. So this is the sill. That's the bottom part of the window. This is a break line here. So there's a break point, another break point here. This is the middle section where the two pieces of glass come together in this type of a window. And then this is the head condition. So this is the very top detail of the window. This has been taken cutting directly through the window assembly. So it gives you an idea of what's going on inside of this type of window. And then there's the various pieces of the window. The bottom piece is the case as the sill. The side pieces are known as casings, or side jambs. The side jambs are the pieces of the frame. And then the stop molding is the piece that the window would stop against. And the head jamb, it's the very top piece of trim there. So siding, exterior siding. When exterior siding is nailed on to the building, it has a thing called exposure. So the exposure is the amount of siding that's exposed to the weather versus overlapped on the next piece. So the amount of exposure, say, of a 7-inch piece might be 5 inches, and then 2 inches overlapped underneath. And this so that it seals the water out in this kind of a configuration. Other ways that we do board and batten type systems. Okay, we've got board and batten. So you have a series of boards marching along here, and then the battens are these other boards which cover up the joints in between these boards. So this is an old-fashioned kind of cottagey siding system. And then reverse board and batten, similar thing, but they put the battens on the inside and then the boards on the outside that keeps it sealed out. And then plywood, texture 111 plywood. It's simulating the reverse board and batten, but it's just 4x8 foot sheets of plywood instead of all these individual boards and individual battens. So it's a lot more effective. Slap that baby up there 4 foot by 8 foot at a time than it is to march along board by board by board. It's a labor issue. Other types of siding, we have plastic and fiber cement and aluminum siding. So these kind of sidings, they attach onto the plywood and you flash them. The flashing keeps the water from entering into the system. And so there's also an exposure here, right? The siding is lapped on top of each other, similar to the wood siding. So it could be aluminum siding where the pieces hook together. And this other one could be horizontal hard board, which looks like siding, which also comes in 4x8 sheets. So instead of having all those boards, once again, boom, you slap up a sheet and call it done. Nail it up. So planters, garden stuff, exterior stuff. What we need to do is be cautious of not creating a situation which creates a pond of water inside the planter, because this is going to cause any kind of plants in there to rot out if the water just collects here and can't get out. So we have to have weep holes, which in this case they use copper tubing, and then make sure that the water and the dirt and everything can leach out into the ground below. So we wouldn't want to really waterproof this situation too much in the planter bed under here. You want that, just some stucco on top of that. There's say plastic foam. I don't know if this is a very good idea because, this is going to create like a pool in here. Very bad situation. You want this water underground to get out of there and not to collect too much. So yeah, sometimes I will disagree with some of the details in this book, just from experience. There's not many, some plants are okay with having their roots wet all the time, like a swampy loving plant, but we shouldn't be putting those types of things in here in Southern California in a drought situation. So that gets us up to 28, unit 28 in the book, and so I'm going to introduce the next homework. The unit 11 homework. It should be available to you now. And assignments. Let me make sure I do my student view here. Okay, that's good. Looks like it's there. And the homework 11 is going to be due November 12th. So you have some time to do this and still do the midterm stuff too, So this, once again, this is based on the lake house. So measurements and questions about the lake house. Sometimes these figures, they reference these figures here to answer the questions. And then this is unit 12. So we're talking questions about footings, questions about elevations. And then more questions about the lake house. All right, and then all three of those sheets, you answer those. Blue beam is a great way to do it, or if you have something else that you prefer, that's fine too. I highly recommend the blue beam.
When is it due?
It's due November 12th. Gosh, it's almost done. No, October's almost done here. All right, so that's it for the lecture portion. You're free to work on your assignments or other classes, whatever you want. And I'll be here. I'll turn the light on.
Oh, what do you mean? They need me to.
Yeah, yeah.
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 I gotta go.
Thank you very much.
Oh, yeah.
Yeah, I gotta go.
That what?
If you're a project, I
No,
wanna take off.
I don't think I'm taking that.
I'll get.
I didn't mean, I think like in all these a couple years ago.
I better know how to take that.
Sure.
Are you serious?
Yeah, everyone, I knew, like, everyone was there seeing, was thinking, yeah. I saw that.
You done a calculus?
Just wait.
Okay.
After probably about 10 years where I'm gonna like stay. Flipping my.
Just tell me I need to do.
Joe,
I'm gonna.
you're gonna have to watch.
I already did the calculus.
I don't know why I asked you.
Unless I did it. I don't think I did it. Policy, y'all. There's two types of deal. I don't know what you are. There we go. No geometry. Are you gonna be there early class next week? If you wanna work on get it solved, or maybe even some of the questions. What do you want?
You're. What's your schedule like?
I'm here Monday, I end class at 12:20, I'll have there 4 o'clock project Monday, and then I'm here Wednesday. Actually, no, I'm not here next Wednesday. Yeah.
You're Monday to Friday.
I might show up Tuesday or Thursday, I don't need to come to school, but I have to work on my job, but I might be there.
Thank you.
Thanks. Have a great one.